Homework was due today. I was like freaking myself on the walk over because like
Wait,
I wasn't
did
sure.
you think it wasn't due today? Or?
What? No, I was just confirming.
Oh, yeah.
Because like I was freaking myself out that like maybe there was a second page. No, once I like figured out what I was doing, yeah.
I made a mistake on 2 at first, then I figured it out.
What'd you do?
I thought it was E, but it's actually B.
B? Yeah, that's what I got as well.
I put in like 100,000 instead of 180, so I fucked it up. But then I figured it out. And the other ones are pretty
I
easy.
thought there was something that we had to do with the 100,000, but I'm happy as lucky as is.
So assignments are here. So I see that you put it here, it's good. You don't have to do it to print it. If someone asked me if it's okay, of course. I think handwriting is easier with all of the equations. Just make sure that the handwriting is clear and the numbers are clear because I need to identify your solution. So after the class or by tomorrow, I will post the solution to the assignments. And also tomorrow there will be a new assignment on bonds. Okay, so it's very important to remind you, it's very important to go over my solution, make sure everything is understood. Also, when you get your assignments back, you can compare. After you see everything, if something is still not clear, let me know, and I will clarify. Okay, so usually I got some questions this week about the assignment. So there's two types of questions. Some questions are clarifying questions. For example, when is the first payment after 1 year, or wait, time 0? Or of course, I will tell you when is the first payment after 1 year, because it's clarification. But if you ask me questions like, so I should use the annuity formula here, this question I cannot answer because this is part of what I'm trying to evaluate your progress. Okay, so this is part of the answer. Okay, so clarification questions are fine, but how to solve it, this is what you should do. This is the assignment, okay? So for those of you that I told you, look, I cannot answer this question, this is why, okay? Because this is part of what you need to do. Clarification questions, of course. Also, if I see after grading your assignment that there was one question, or one part of the question that there were difficulties, specific difficulty in this question, I will choose in the next class to go over that question. But usually we'll not go over all of the solutions, because I will assume that you read my solution. That's why I provide detailed solutions. I assume that you read the solutions and everything is clear, unless you tell me otherwise. Okay? Make sense about the assignments? Any other question about the assignments? So no email, not submitting ASCII CT, just hard copy here. And when I grade them, I will tell you here, these assignments are graded, and then you can take your assignment and see your grade. Okay? So when you submit the next one, hopefully this will be graded, and you can take this assignment. Okay, so we'll continue the bond discussion today. So we made some progress last time. We talked about the bond pricing mechanism. We had the general formula of the bond pricing that we will use over and over in this session. And this is the general formula. Okay, so we have the bond price, like any other assets, will be given by the present value of the payments that the assets, in this case financial assets bond, is generating. We have two parts of payments. One part is the coupon rates, the coupon payments. These are the C's. Okay, they go from times 1 to capital T. And then you have the face value. So the present value is this sequence of the individual present value of the coupon payment and the present value of the face value. Because the coupon payments follow an annuity pattern, then we can use the shortcut for an annuity present value. C over R times 1 minus 1 over 1 plus R with the power of capital T, plus the present value of the face value. So this is the general bond pricing formula. And we did some examples. I gave you everything on the right-hand side, and you know how to calculate the bond price. And we did something more. We said that if we know everything on the right-hand side, coupon payment, face value, time to maturity, but we don't know R, the discount rate, but we know the price, then we can calculate the discount rate, which is the yield to maturity. Okay? How are we going to do it? It's not as easy as the bond price, because we cannot isolate R as we isolate the bond price. So we need to do it by trial and error. So we use Excel and we did an example. Okay? And then we talk about how the bond prices are changing. The fundamental fact was that when the interest rates are going up, the bond prices are going down, because the interest rates are in the denominator, and conceptually, if the interest rates in the market is higher, then elsewhere can do better. So if elsewhere can do better, the opportunity cost of capital of giving up these opportunities will be higher, so the present value of the bond investment will be lower. And we did some examples to see this inverse relation. And the last thing that we started discussing last time is that although the fundamental fact is true for all bonds, meaning when interest rates go up, the bond prices of all bonds will go down, and vice versa, it doesn't mean that the magnitude of the change will be the same for all bonds. So if we have bond A and bond B, and the interest rate is going up, yes, the price of both bonds will go down. But it might be that the magnitude of the change in the price of bond A will be much more significant than the magnitude of the change in the price of bond B. So why is that? Why some bonds will react more aggressively to a change in the interest rate, and some bonds will react in a very minor manner to changes in the interest rate? What is the property of the bonds that tell us something about the sensitivity of the bond price to the changes to the interest rate? So we're floating few aspects here, all of them are correct. Maturity, coupon rate, discount rate, right? So we're going to build it step by step, and this is what we started to do last time. Okay, so we started with first example of two zero coupon bonds. Okay, one bond is for 2 years maturity, and the other bond is for 10 years maturity. So the first question that we ask is, what is the price of these two bonds when the starting point is that the discount rate is 9%, right? So under 9%, bond A, the price of bond A will be 1,000 over 1.09 to the power of 2, right? And this was, I think, 841, if I remember correctly, right? We did it last time. Let me just verify that it's indeed 841. Yes, 841.68. Bond B is $1,000 over 1.09 with the power of 10, and this is 422.41. Of course, the value is lower because we get the same $1,000 in 10 years, right? So now I ask you at home to calculate. We are here now. To calculate the price of the bond when the interest rate is going to 12%. So what do you think? Which bond will lose more value, percentage-wise, A or B? A, why A? Any justification? Yes?
Shorter periods.
So shorter periods, so you lose more value when the time value of money changes. Okay, any other suggestions? Other intuitions? Maybe the same. So let's do it, let's see. So bond A, now it's 1,000 over 1.12 with the power of 2, right? And this equals to 797.19. And bond B, which with 10 years to maturity, is 321.97. So this rough estimations about $40-something out of something a little bit more than 800. So the change, let's put it, the return is about minus 5%, right? More or less, 40 out of 800. And here you lose $100 out of about 400. So here the return is about 25%. So if you put $100 or $10,000 in this bond, you would lose 5%. You would left with $9,500. If you put $10,000 in this bond, you will lose 25%. So we're left with $7,500. So bond B is losing more. Why is that? Why bond B is losing more than bond A? Yes?
Because it's compounded 10 times instead of 2.
Exactly, because look at the R here. The formula, 1 plus R. If you change R a little bit and it's compounding 10 times, the effect will be much stronger, right? Comparing to 2 times. And intuitively, if the bond is 10 years to maturity, so the value now is given by discounting 10 times to the present. So there's a lot of time value, right, for 10 years. So if we're changing the time value of money, the effect will be bigger because we have more time until we get it. Comparing to 2 years. Think about $1,000 that you're getting right now. Immediately, what is the present value? 1,000. And if the interest rate goes up, it's still 1,000. It's not sensitive at all to changes because there's no time. So the time value of money is not relevant here. Okay? Does this make sense? Yes? So what have we learned from this? We learned that if we have only 2 zero coupon bonds, for zero coupon bonds, what is the property that determines the sensitivity of the bonds to the changes in interest rate? Yes? Time to maturity. That's it, right? Because you have only one payment, the longer the payment, it's more sensitive to changes in the interest rate. Right? So we made some progress. For zero coupon bond, we found a property that determines which bond will be more sensitive to changes in the interest rate. The question is if this applies also to all bonds. Okay? What if we have general bonds that pay coupons? Whether in this case it also the time to maturity. So let's see. So we'll do a second example. So now, if you look at this second example, we have 2 bonds, but bond B is the same as bond B here. Okay, same one. Zero coupon bond, 10 years to maturity. Bond A, we replace it. We replace it with a regular coupon bond, but longer maturity, 12 years. But this bond pays coupons, unlike bond B. So the question is, whether bond A will also be more sensitive to the changes in interest rate because it has longer maturity. Maybe yes, maybe not. Let's see. Okay, so we'll do the same exercise. And see which bond is more sensitive now. The price of bond A, now we have 12 years to maturity, so it's better to use the shortcut, right? So it would be 15% coupon payment. So what should I write? What will be the formula? 150, correct? Over what? 0.15? Why? What is here? The bond pricing formula is C over R over 1 minus 1 over 1 plus R, capital T, plus face value over 1 plus R, capital T. So what is R?
0.09.
What?
0.09.
Yes, R is the discount rate. It's not the coupon rate. It's the discount rate. Okay, remember where it comes from. C over 1 plus R, plus C over 1 plus R squared, and so forth. R is the discount rate, deal to maturity. So here it will be 0.09. Then we have 1 minus 1 over 1.09 with the power of 12, because we have 12 years, okay? Plus 1,000 over 1.09 with the power of 12, and I think this is 1,429. Okay, now we'll do the same, where the interest rate, the discount rate is 12%. And see which bond is more sensitive. So bond A, now I'm changing only the discount rate. This is it. Okay, the coupon payment, everything is the same. Maturity, face value, everything is the same. So 150 over 0.09, 1 minus 1 over 1 point, I'm sorry, 12, changing the discount rate. 112 with the power of 12. So it's not the same 12. 1.12 is the discount rate. 12 here is 12 here is 12 years. Plus 1,000 over 1.12 with the power of 12, and this is 1,185. Okay? So this is, if you do the calculation, the return is about negative 17%. So which bond is more sensitive, A or B? B. It loses more value, 25% comparing to 17%. So the bond with the shorter maturity, 10 versus 12, is more sensitive. So first thing that we learn from this, whenever coupon bond involves, is not necessarily the maturity. Right? Because here we have an example that one bond has shorter maturity, but is more sensitive. Okay, so we cannot carry this rule from the zero coupon bond to the general case. Make sense? So why is that? Why, although bond B is shorter maturity, is more sensitive to the changes in the interest rate? What is causing that? Why is that? Any ideas? Any intuition? Alexis?
The coupon rate?
Yes. Bond A pays coupon. That apparently it must be the case that it makes it less sensitive, because what else, right? So Alexis, do you have any intuition why the fact that bond A pays coupon makes it less sensitive to the changes in the interest rates?
Not that I can think of right now.
That's okay. This is the discussion, right? Louis?
Is it because you get money now?
Earlier. Not necessarily now, but you get it earlier because you get coupon all the time. So yes, you're getting money earlier. So what?
So thus therefore, if changes in getting money now is not affected by changes in.
Correct. Some of the bonds components are not as sensitive to the interest rate as the one of the face value, right? In other words, bond B, its entire value coming from 10 years. One payment, that's it. And that 10 years payment is very sensitive to the changes in the interest rate. Bond B, I'm sorry, I'm talking about bond B. Bond A, it's not the case that its entire value is coming from one payment in 12 years. Some of its value coming from 1 year, 2 years, 3 years, 4 years, all the way to 12 years. So because some of its value is coming earlier, that part that coming earlier is not as sensitive to the changes in the interest rate. So the higher the coupon rate, it makes the bond less sensitive to the changes in the interest rate. Okay, so it's not enough to look at the maturity. Does this make sense? So, we need to move forward. So if the maturity is not the case, what is? What is the property that we're looking for? So I will suggest you something based on that, and you tell me if it makes sense. Okay? So because we should not look only at the maturity, but also on all payments, all the way to the maturity, how about if we look at the average maturities of the payments? Makes sense, right? So let's see if this works. So I'm going to show you here. Can I erase this? So I'm going to show you here two bonds. And we look at the average maturities of the two bonds. And you're going to tell me which bond you think is more sensitive to the changes in the interest rate. So we start with bond A. And this is the timeline. So we have, this is time 0, time 1, then we have time 50 here, then we have 99, and that's it. So this bond pays one payment of $100 after 1 year, and this bond $100 after 99 years. So two payments, equal payments, $100 after 1 year, $100 after 99 years. What is the maturity of this bond? Maturity. Yes, remind me?
No, even?
Ethan.
This is 100 years.
99.
Oh, not, but,
There's nothing here.
oh, okay. I thought you
99.
said maybe last.
No, there's no payment. It's 99. Okay, yeah, we can get rid of this.
Okay.
But one last payment 99. So the maturity is 99. Ethan, can you tell us what is the average maturity?
49 and a half.
How did you come up with 49 and a half? You're close. You have one payment in 1 year, one payment in 99 years. We need something between 1 and 99, which is, what is the average of 1 and 99? 99 plus 1 divided by 2? 50, right? So the average maturity is 50, right? We put the same weight because we have 100 and 100, correct? So the average maturity is, let's call it T. Average is 50 years. Alright? Now let's look at the second bond. We have one payment of $200 here. One payment after 50 years. What is the average maturity of this bond? This is the average maturity of A. What is the average maturity of B? What is the maturity? The maturity. The maturity is when is the last payment of the bond. So what is the maturity? 50, right? Last one payment, last payment, the maturity is 50. What is the average maturity? Why 25? The average maturity means that you need to take all of the payments and to do the average of each maturity. How many payments do you have? How many payments? One. Only one payment. There's no payment in year 1, 2, 3, right? So if you have only one payment after 50 years, what is the maturity? 50, right? So the average maturity here is also 50 years, because what is the average of one number? Is that number. Right? So both bonds have the same average maturity. Agree with that? Yes? Now, here's the important question. Which bond is more sensitive to the changes in the interest rate? If the interest rate is 2%, then it goes to 5%. Which bond loses more value? A or B?
B.
B. Remind me then? Molly, why B? Oh, you said? Yeah, remind me then? Yeah. No. Why B? Why B loses more value? Yes, Alexis.
Because you're getting the full, like the whole payment in 50 years, like only one payment, so it's more susceptible to like all the changes that can happen.
So it will lose a lot of value because 50 years.
Yeah.
But how much this bond will lose? This 100 will lose a lot.
Yeah.
But
But
this
you're
will
still
not
getting
lose much.
Yeah, you're still getting a payment at first.
So, okay, survey. How many of you think that bond B will lose more value? How many think that bond A will lose more value? How many think it will be the same? You want to provide some intuition for each one, each scenario, each answer? Yes, remind me then?
Mason,
Mason.
I agree with what she said because you're getting an additional payment now.
So you agree with Alexis? Okay. Bond B will lose more value, and here is why. So all of you that said bond B, it's pretty much it. Why? If you take it bond A, where is most of its value coming from? This payment or this payment?
The first one.
This one. If you look at the value of bond A, 99% of its value is coming from this payment. This is really not important. If someone will take this from the bond will be almost the same value. Right? The present value of this is maybe $99. The present value of this, maybe 5 cents. I don't know. It's 100 years of some interest rate, right? So you think about what contributes more to the bond value. This by far. Most of the value is coming from this payment. So when you have change in interest rate, it doesn't change much, the value of the bond. But this, all of the bond value, as Alexis said, is coming from one payment after 50 years. So slight changes in the interest rate, this bond will lose a lot of value. Okay? So the average maturity is not a characteristic that we're looking for. We need to modify it. So what we need to look at that will tell us which more sensitive? Not the average maturity, but we need to take the average maturity and weight it by the, not the simple average, but the,
The number of payments.
not the number of payments. Each payment should be taken not with the actual amount, but each maturity payment should be taken with its present value. Okay? So not the average simple maturity, but the present value weighted maturity. Because this is what's important. This is what contributes to the bond value. So, this measure is called duration. And the duration of the bond is the present value weighted average of the maturities of the individual bond payments. And how we calculate the duration? We look payment by payment. If you have a bond, 1, 2, 3, all the way to capital T. And we have payments, C1, C2, C3, and eventually we have C capital T, it can be the face value plus the coupon payment. So basically we take the present value of each payment. So the present value of this will be C1 over 1 plus R. And we multiply it by here 1 year. Because this is the present value that's coming from 1 year. Then we have the present value that's coming from second year, plus the present value that's coming from the third year, and this is times 3. All the way to the present value that's coming from capital T years. We take all of this and we divide it by the value of the bond, because we want to see the present value, how much it contributes to the bond as a fraction. So the result here will be number of years, maybe 2.7 years, that will tell us what is the average maturity of the bond when we're taking into account the present values. So the duration of the bond, in short, using the sigma sign, in short, it's written like this. It measures the degrees to which the market price of the bond is sensitive to changes in the market interest rate. Okay? So this is the property, the general property that we are looking for. So the duration of the bond is one of the major concepts in the bond market. Okay, any questions? So we build it step by step, hopefully providing more intuition why is the right measure. And this is enough. If I tell you look, there's two bonds, bond A and bond B. Bond A has duration of 8 years, bond B has duration of 5.5 years. It's enough for you to know that bond A is more sensitive to the changes in interest rate. You don't need any more. Okay? Once you know the duration and you compare bonds, you know which is more sensitive. In other words, the duration is the equivalent of maturity if the bond was a zero coupon bond. Okay? Because a bond with a zero coupon bond, the maturity is the duration. So let's say a bond has 5.5 years duration, but it has many, many payments. It will be sensitive to the interest rate as a zero coupon bond with one payment after 5.5 years. So you see the equivalency? Okay? Make sense? Okay, exercise. Example. What is the duration of a bond with reach to maturity that has a 9% coupon rate if the interest rate is 8%? So look at the formula. What do we need to know to calculate the duration? What is the first thing that we need to know? Look at the formula. First thing is the bond price, right? And then we need to calculate the present value of each payment and multiply by the corresponding years. So let's see how we're going to do it. So the bond has face value of 1,000, right? We said if not mentioned otherwise. The maturity is 3 years. The coupon rate is 9%. And the yield to maturity, the frequency of the payment is annual. It doesn't say otherwise, 1 year. Okay, and R is 8%. So, how the payments looks like? 0, 1, 2, 3. Right? So we have 90, 90, and here 1,090. Why 1,090? 1,000 the face value plus 90 the last coupon payment. Is that clear? I combined them. Any questions about the payments? The payment schedule. If you have questions, this is the time. Because you need to know how to schedule the payments of the bond. So if you don't know why it's 90, let me know. If you don't know why it's 1,090, let me know now. Yes?
Is the 90 just the 9% of 1,000?
Yes, exactly right. Okay? The coupon payment is the coupon rate times the face value. And at the end, you have the face value plus the last coupon payment. Okay? Does this make sense? Okay, so now we need to calculate the duration. Before we calculate, yes?
So for the frequency, it's just like normally.
If I'm not saying otherwise, let's assume it annual. Okay? For simplicity. But you can adjust it to any period. But, okay? Yes?
The third payment of 1,090, that's not actually a third payment, right? Is there way more payments? And how could it go from you're paying 90 to close to 1?
Because at the end, you also get the face value. You get your loan back.
Oh, so you're paying the 90 and you're also getting a loan.
Yes. The face value, remember when we built the payments of the bond, we said, what is the major payment? The major payment is the face value that the issuer will pay to the bondholder after a certain number of years. This is the first payment. Okay, this is, you can view it as your loan you're getting back, but every period you get also interest on your loan. Okay, so I just combined the 1,000 with the last coupon payment. Okay, so before calculating the duration, let's see if we can have a good guess what will be the duration. So I'm going to ask you a question and you tell me if it's right or wrong. Can the duration be over 3 years? Why not? Rebecca? Why not?
Because that's what the face value is.
So mathematically, why it cannot be over 3 years?
The bond no longer exists.
Because the duration will be average of 3 numbers. 1, 2, and 3. This is where you get the payments, right? Each year will get some value, right? Some proportion. What will be the proportion? The present value of the payments in that year. So if you take average of 3 numbers, 1, 2, and 3, it doesn't matter which kind of average. Simple average or weighted average, the average cannot be the maximum, right? So we don't expect the duration will be more than 3 years. And also, it cannot be more than 3 years conceptually because we ask what is the average of the payments. It cannot be over 3 years if the last payment is after 3 years. Okay? Okay, so it's no more than 3 years. You think it can be, let's see, so we have 3 payments. You think it can be exactly 3 years? Yes? For this case, it can be exactly 3 years? Hamza? No? You said something? Okay. I thought so. You think it can be exactly 3 years? Yes? Why yes? Why it can be exactly 3 years? We take average of 3 payments. Year 1, year 2, year 3, correct? So it will be average of 3 numbers. Now if year 3 will be 100%, then it will be 3 years. But there is some value here, positive value, right? So it won't be exactly 3 years. It must be lower than 3 years, right? If you take an average of 3 numbers, so 1 gets some value, 2 gets some value, 3 gets some value, it must be between 1 and 3. Right? Agree with that? Okay. Last question before we calculate. So we know it will be between 1 and 3, right? Because we have only 3 numbers. So you think it will be closer to 1 or closer to 3? The duration. Yes?
It's gotta be closer to 3.
Why?
Because that's when the bulk of the payment is received.
Excellent. Excellent. Look at that. Year 3 will get way more value in the weighted value calculation than year 1. The payment here is much bigger. Even after you take discount by 8%, the present value of this will be much bigger than the present value of this and present value of this. So it will be way closer to 3 because it gets more value. Below than 3 because we have positive value here, but closer to 3. So this is what we expect. Very good. This is what we expect. Closer to 3 than to 1. Okay, so now let's do the calculation. So the first thing that we need to do is calculating the bond price. So now we don't really need to do the shortcut. We can, right? Because we have the annuity 3 years, but we can, it doesn't save us much. It's not like 20 years. So we can do it in the regular way, one by one. So we can do 90 over 1.08 plus 90 over 1.08 square plus 1090 over 1.08 cube. Okay? Any questions? I didn't do the shortcut. If I do the shortcut, it will get the same result. But the shortcut just for free period doesn't save us much. So this equals to 1025.77. So this is the price of the bond. Now, for the duration, 1 over V, so 1 over 1025.77. And now we need to look at year by year, take the year times the present value of the payment from that year and so forth. Okay, so 1 year times what? 90?
Well, 90 and then over, like,
The present value of the 90. So 90 over 1.08. Then what?
me.
If you want.
2 times 90 over 1.08 squared.
Yes. 2 years. What is the value of 2 years? What's the present value of the payments of the 2 years? 90 over 1.08 squared. And then, what is the next one? I thought
It'd be 3 times.
3 times
Times 1,090.
1,090. We can combine them because the payments the coming 3 years are 1,090. So we can write 390 and then 1,000. We can combine. Very good. So 1,090 over 1.08 U. Okay? So this is the duration. You see how it works? And this, according to my calculation, 2.76 years. So really, the duration here, around here. Duration 2.76 as we expected. Okay, closer to 2 years than to 1 year. Yes.
And then just, so that's how many years it's like sensitive to changes in the market?
That means that this is equivalent to a bond with one payment as if would have paid 2.76 years.
Okay.
Okay? It's taking everything and putting in one equivalent point. So it's instead of the average maturity, it's the weighted average, the present value weighted average maturity, because it's important what is contributed to the bond value, right? Because every payment is coming with different discount. Okay? But so if I'm asked a question, now, I have another bond. I didn't show it to you. Here I showed you everything about this bond. So I have another bond in my notes. Didn't show it to you. But I tell you that the other bond, the duration is 3.15 years. Now I don't tell you what is the maturity. I don't tell you what is the coupon rate. Nothing. All I tell you that the duration is 3.15 years. Which bond is more sensitive? This bond, it's enough. You don't need to know everything else. This property tells you everything about the sensitivity. Once you have this property, you can compare. That's it. Okay, so remember, what is the task? To find the property that determines the sensitivity of the bond to changes in interest rate. Okay? Before we move on, any questions about the duration? Yes?
So just like you said, like if we have the durations for two different bonds, we can compare duration versus duration.
Yes.
And then like that will tell us which is more sensitive.
Yes, exactly. And this is all you need to know.
Okay.
You don't even know the maturity, the coupon, nothing. The frequency. All you need to know is the duration, and this is enough for comparison. It's everything is summarized in the duration.
Okay.
Okay, that's why we said, what are we after here? After the property of the bonds that determine its sensitivity to changes in the interest rate. Yes?
Is more sensitivity undesirable, or I figure out?
That's excellent question. Excellent question. Is better to be more sensitive or less sensitive? And it depends on your portfolio of assets and liabilities. And you know what? I was about to talk about it maybe in 2 slides, but because you asked, let's talk about it right now. There's many things to do with the duration. We're going to touch you maybe on one thing, maybe 2. But for those of you that will take the fixed income security class, you'll see how many things you can do with the duration, why it's so important for not just in the financial market, but also for corporation. What does it mean it's good or not? One of the things that you can do with the duration is to match the duration of your liabilities to the duration of your assets. And why is that? Because in this way, if the interest is going up or down, your asset and liabilities cancel each other. So you're safe. You reduce the risk. And this matching is called portfolio immunization. You immunize your portfolio, the asset and liabilities won't be affected by the interest rate. So for example, if you have a lot of assets, okay, tens of millions of dollars of assets, what is the risk there? And let's say the duration is 20 years of the assets, okay? What is the risk? That the interest rate will go up, and then the value of the asset will go down. If you have liabilities, also $10 million is 20 years. What is the risk? That the interest rates will go down, and the present value of liabilities will go up. So one thing that companies do, they match the duration of the assets and liabilities. They put 20 years for both. So if things go up and down, the asset and liabilities go up and down together. They cancel each other. So it's good or bad, depends on your portfolio and the other parts of your portfolio. Okay? So it's a good question, but this is things that we can do with the duration. Okay, we'll talk about more things that we can do with the duration. But for now, let's see what affects the duration. Why the duration of the bonds will be high or low. So we look at the formula of the duration. By the way, everything is in parentheses over there. So even the sum is, everything should be in the parentheses, okay? So maybe it's not clear. Even the t times f over, this is also in the parentheses. So it's, just make sure it's clear. See, we know 1, 2, 3 because for the bond is the same coupon. Okay, so everything in parentheses divided by the bond price. Okay, let's make sure. So now let's ask some questions and see if it makes sense. What affects the duration of the bond? A zero coupon bond has duration equals to its maturity. Make sense? Yes, why? Why for a zero coupon bond, the duration is the maturity of the bond? Yes?
You're only getting one payment.
One payment. So the average of one payment is that number of years. And if you look at the duration, let's see. If we have one payment, so all of this part is gone, right? We don't have coupon payment. So what we're left with? We're left with 1 over B times T times F over 1 plus R with a capital T, right? But if we look at this part, how can we call it in a different name? For zero coupon bond, this part is exactly what? Say? The price of the bond, right? What is the price of the bond of zero coupon bond? F over 1 plus RT. So basically we have here 1 over B times T times B, which is cancelled, and this is T. Okay? So it also works mathematically. Okay, make sense? So this is clear. A zero coupon bond has a duration equals to its maturity. Coupon bonds have duration shorter than the maturity. Why does this make sense? Luis?
Because you can have, you take average of multiple numbers of maximum.
Because you start getting average of multiple years. So you're getting lower, right? If it's zero coupon bond, the duration of the maturity, once we have coupons, then it will be the average of that maturity in earlier years. So the duration will be shorter. Okay? And duration increases with the maturity. For everything else constant, the longer the maturity, the longer the duration, right? Okay, that makes sense. Duration is inversely related to the coupons. So for everything else constant, if the coupons are higher, there's more value to the earlier payments, right? More value is coming to the bond from earlier payment because we have heavier payments in the early years, right? If we have a bond that doesn't pay 90 here, then instead of the 90 it pays $300, and then 1,300, then relatively now we have heavier payments in earlier years. So it will get the duration closer to 0, okay, or to 1. That make sense? Okay. The last one I would say is the least intuitive of all. Duration is inversely related to the yield to maturity. And this is not very intuitive like the others, so we'll spend maybe a little more time on that. Why duration is inversely related to the yield to maturity? If you look at the yield to maturity here, when the yield to maturity increases, so all of this part here, what happened to it? If the yield to maturity increases, what happened to this part in the parentheses? Go up or down? If it increases, the yield to maturity. If R increases, what happened to this?
Then the whole thing decreases.
Decreases, right? Because it's in the denominator, right? You see? But if you look at this, if the yield to maturity increases, what happened to the bond price? Go back to the fundamental fact. If the yield to maturity increases, the market interest increases, what happened to the bond price? Decreases. So what happened to this part? If B decreases, what happened to 1 over B? Yeah? Larger. So this gets larger and this gets lower. So how do we know what happened to D? It's not very intuitive, right? But it still said inversely related there. So what is the intuition for that? It's not very intuitive, so let's illustrate with an example. Let's say that we have a bond that pays 0, 1, 2, paying 100 here and 100 here. For simplicity, let's assume the discount rate is 0%, no time value of money. Just to illustrate, what is the duration of this bond?
When you first get it,
Shown, right? What is the duration?
you get zero.
The duration is not 0, right? There is some periods until you get the money. Next one?
42.
The duration will be 2. How did you come up with 2?
Because the discount rate is 0.
Yes, so
No, I'm just doing that.
what is the definition of the duration?
The measure to which the,
No, this is what it's determines. But what is the definition? Is the present value weighted average maturity? What is the present value of this? If there is a 0 discount rate.
100.
What is the present value of this?
100.
Okay. So you need to take average of 1 year and 2 years, give it the same weight because the present value is the same. So what is the average maturity?
100. 100.
Average maturity.
Oh,
Any other guesses? What is the average maturity? This is important because it gives you another way to understand the meaning of the duration. Yes?
Is it 1.5?
1.5. Right? You take average between 1 and 2. But you give exactly the same way because the present value is the same. Right? So on average, you're going to get your money in 1.5 years. Half of it in 1 year, half of it in 2 years. The same value because the present value is 100 in both. So on average, you get the money in 1.5 years. Right? Your loan will be back in 2 packages. 1 in 1 year, 1 in 2 years, same value, 1.5 years. This is the average time that you get your money back. Right? So the duration is 1.5. Now let's assume that R is 10%. What is the duration? 1.5 or no?
No,
Why?
because of the time value of the money,
So it will be what? Bigger than 1.5, lower than 1.5?
bigger,
Bigger. Why bigger?
because your money, you'll be making more money with the more.
I'm not sure you're making, but something's going on here. What is the present value? Which present value will be higher one? Now, present value of this 100 or this 100?
First 100.
The present value of this will be bigger than the present value of this, right? So, which gonna get more weight? 1 year or 2 years?
Year 1.
Year 1 will get more weight in the average maturity because the present value is higher. So the duration will be bigger or lower than 1.5?
Lower.
Which gets more weight, 1 or 2? 1. So it will be lower than 1.5. It will be closer to 1. So also it's hard to see it intuitively. This example shows you that the higher the yield to maturity, the lower the duration. Okay, I agree it's not very intuitive. That's why I did this example. Yes?
These are the interest payments or the coupon payments?
It doesn't matter.
Because I'm saying, when, in the last year, are we paying?
There's no other payments here. I just want to illustrate.
Okay.
You can do duration for any asset that pays payments,
Because
right?
with the time with the payback face value in the last year, when those.
There is no big payment here. I just want to illustrate
Okay.
that if some asset gave you two payments
Okay,
and there was a zero discount rate, whatever discount rate is positive, the duration is
Yeah.
going down.
okay.
Then you can apply it to bonds with face value everything. Right? Just okay. Suppose you have two payments. Okay. More questions? Okay. So, as I mentioned, the main thing that the duration does is determine the sensitivity of the bond price to changes in interest rate. So if you give me two bonds, all I need to do is the duration of the bonds. I can tell you which bond is more sensitive. But we can do other things with the duration. Is one of them is immunization of portfolios. We can do others. And another thing that you can do with duration actually is to estimate the change in the bond price as a response to change in the interest rate. And we do it using this formula. Okay, so the approximate, why approximate? Because it's not a linear function. So for small changes, it will give you good approximation. For larger, the approximation will be a little bit more far than the real price, okay? Because it's not linear indeed. So the approximation change, and this function is there is in the denominator, and then becoming more, the effect will be a little bit higher than it should when the change in R is bigger. And actually in the second assignment, I'll ask you to do two calculations to see how the approximation goes. But for now, let's use this formula. So the approximate change in the price of a bond given the change in yield can be determined as follows. So this is the formula. So let's write it down and do an example to see how it works. So the change in the bond price, this is the dollar change, equals to the minus the duration times the bond price over 1 plus R times the change in the interest rate. So we know that when the interest rates go up, okay, what will happen to the bond price? Should go down, right? Inverse relation. So let's see if the direction here is okay. If the interest rate goes up, okay, what happened? This is negative number, right? Because duration is positive. This is always positive, right? Because R is positive, the price of the bond is positive. Now this, if this is negative, decrease in the interest rate, so negative times negative, it's positive, bond price will go up. If this is positive, interest rate goes up, so positive, positive, negative, bond price will go down. So directions are okay. So now let's see an example how it works. Consider an 8% bond with 25 years to maturity. Assume that the interest rate is 6%. I saved you some time to calculate the duration because it's a lot of terms there. So the duration of this bond is 13.55. Can you do in Excel? Take you pretty short, but I just did it already. How much will the bond's price change if the market interest rate decreased by 2 basis points to 5.98%? Okay, so we have a bond with 25 years, right? Okay, 25 years. So 1, 2, all the way to 25. We have 80, all the way to 1080. And the interest rate, we start with 6%, right? And the duration, I calculated is 13.55 years. So somewhere in between. Okay? So, what will be the change in the bond price if the interest rate is going down from 6% to 5.98%? So what do we need to do? We need to know, let's see, so the change in the bond price will be minus the duration, so minus 13.55, times the bond price, right? We'll calculate it in a second, over 1 point, the original interest rate, 6%, times what? Times, what is the change in R? Negative, right? Go from 6% to 5.98. So negative what? Negative point 0.0002. Because 0.02, it means that you go from 6% to 4%. So it's go 2 basis points. From 6% to 5.98%. Okay? So make sure we have the right measure here. Make sense? So all we need to find is B. Now we can use the shortcut because 25 years. Okay? So B equals, who want to help me here? Yes?
Do you want the formula?
Yeah.
80 divided by
80, correct. Coupon payment divided by?
0.06
Yes.
times 1 minus 1 over 1.06 to the 25th
Yes. 25 years. Then?
plus 1,000 divided by 1.06 raised to the 25th.
Correct. Okay? See, using again and again the bond pricing formula. And how much you got?
1255.67.
Yes. I got the same. 1255.67. So here, I'm changing this here to 1255.67. And this will come to 3.21 $. It's not surprising that the price is expected to go up because the interest rate goes down. Okay? By how much it will go down? By approximately $3.21. Okay? Is this example clear? Any questions? Any questions about duration? So once again, duration, it's a major concept in the bond market, but not just in the bond market. For every asset and every project generating future payments, you can calculate the duration. Meaning, if you want to convert all of the sequence of payments to one payment in the future, when this payment will be. Okay? This is the meaning of the duration. Okay, so we have 2 more things to do with respect to the bond pricing. One is talking about the APR and equivalent yield, and one is talking about the term structure of the bond. So we'll start, how much time we have? We have about 6 minutes, so maybe the term structure will do in mind. So, APR and bond equivalent yield. Bonds are usually repaid twice a year. Okay? Usually, not all bonds, but most bonds are paid every 6 months. Okay? T-bonds, T-notes, corporate bonds, okay? Semi-annual payments. Therefore, we calculate the yield to maturity of the bond, the implied discount rate, in semi-annual terms. Okay, because it should match the frequency of the payment. So we have semi-annual yield to maturity. What the financial press does is taking this semi-annual yield to maturity and multiply it by 2 to get the annual yield to maturity. Okay? Just multiply it by 2. But what it misses here? What kind of yield to maturity is what the financial press does? Multiplication of the semi-annual yield to maturity, which is called, by the way, APR. Okay? So if you saw the APR in your mortgages, or car payments, or any loans that you have, the APR, the annualized percentage rate, is basically the semi-annual yield to maturity multiplied by 2. Or, in general, whatever frequency, monthly frequency, yield to maturity, multiplied by 12, whatever. So what kind of rate is the APR, also called the bond equivalent yield? It's nominal rate or effective rate? What do you think? Once again, I'll tell you the calculation. Bond is paid every 6 months. So we calculate the implied, like we did with the Excel, the implied discount rate using semi-annual payments. So we get semi-annual yield to maturity. Multiply by 2, we get APR. Is APR nominal rate or effective rate? Let's do an example and figure it out. Suppose a bond is paid every 6 months with for 2 years. Okay, no, for 1 year. And the face value is 1,000. The coupon rate payment is, let's say, 6%. So face value is 1,000. Time to maturity is 1 year. Coupon rate is 6%, and the frequency of the payment is every 6 months. Okay? So, we have 6 months, 1 year. So how the payments will look like? Well, here we're going to get the face value, right? 1,000. But what are we going to get here and here? 60 is the annual coupon rate.
Oh, 30.
30, right? We're going to get 30 here and 30 here. Right? Now let's assume for simplicity that this is a par bond, so the price is $1,000. Okay? Make sense? Just for simplicity, to illustrate it. We can put any number here, but then it will be not that round. So I just want to illustrate the point. So we need to find the yield to maturity. What is R? What is the yield to maturity of this bond? So we do a semi-annual formula here. So how do we find it? 1,000, remember that we did in Excel, equals to 30 over 1 plus R, plus 1,030 over 1 plus R squared. So this will give you R. You can guess? I can do it in Excel, but take a guess, it will be this. What do you think will be R here?
3%?
3%. Exactly right. Okay? Why did you say 3%?
Well, $30 is 3% of 1,000.
It's a par bond. Right? If the market value equals to the face value, the discount rate must be equal to the coupon rate. So here it's semi-annual, it's 3%, it will give you 3%. Okay, it's a good intuition. So how would be 3%? Okay, so this would be times up. Okay, so this would be one, you know what? 1 minute, I'll give it back on Monday. This will be the yield to maturity of 6 months. Okay? What the APR is 3% times 2, 6%. Okay? Now for the next time, think if the APR is 6% is the effective rate or nominal rate on this investment. The same? Nominal?
I think, I don't know.
6?
Why nominal? Because it wasn't nominal like what you expected to be, I thought. Yeah.
Put $1,000. You're making 6% or 50 or more.
Really calculate it?
If you get $60,
Yeah.
you make 6%. I think you get 30.
Oh, you make more? Oh.
You're right.
Okay.
6% is nominal.
Yeah. Yeah, exactly.
We need to make some adjustments.
Yeah. Okay.
Okay.